Alright, so today we're introducing a new idea. Okay, we're going to use the altitude of a triangle and we're tying that to the geometric mean. Now we've talked about these in two different units. We talked about the altitude in Unit 5 and we talked about the geometric mean in Unit 6. So really here in Unit 7 we're going to combine those two ideas together. Okay, we're going to do this over 2 days. So this is day 1. We're going to look at one type of problem today. Tomorrow we're going to continue this discussion, but we're going to look at a second type of problem. Okay, so it's really important as we go through the next 2 days that you pay attention to what you're given in the problem, because really what you're given is going to dictate which type of problem we're looking at and then how to solve that problem. Okay, we're going to start with a little bit of review. First thing I want you to recall is how to do the geometric mean. Okay, now remember, when we have a proportion, any proportion, we called these the means, okay, B and C. What geometric mean is we're finding the value, and it has to be the same value there for B and C to make a proportion true. So I put 3 up here on top and an x down here on the bottom, and that's got to equal x over 12, because my means has to be the same value. So we solve this, we cross multiply. X times x is x squared. 3 times 12 is 36. Now to get rid of a square, we square root. 36 happens to be a perfect square. It comes from our list, so our answer here is 6. And that's how we find the geometric mean. Okay. Now, we've been doing problems and dealing with problems that have a lot of radicals in them, so they may have a radical in them that doesn't simplify. That first one was nice. 36 is a perfect square. Giving you a little hint here, the next two are not going to have nice radicals that simplify completely. So we do the same thing here on the second example. 5 over x equals x over 8. Really, this can be an automatic setup when we're finding the geometric mean. The two numbers fill the extremes, the x's fill the means. Okay, and it's the same setup every time. We get x squared. 5 times 8 is 40. We square root both sides. Well, x equals the square root of 40. Now 40 is not a perfect square, so we want to break it down. And we're going to use finding all of the prime factors to do that. So I broke 40 down into 4 and 10. Again, that's not the only way. You could have used 5 and 8. That's what you multiplied to get 40 in the first place. But any way you break it down is going to result in the same set of prime factors. And then we look for a pair of numbers to make a perfect square. Well, 2 times 2 is 4, and the square root of 4 is 2. So 2 is going to go out in front of my radical. The 2 and the 5, they do not make a perfect square. So they get multiplied back together, and they are a 10. So 2 square root 10 would be my answer. Now in Schoology, if you had a problem like this, remember that this would be your A and this would be your B value. That's how we would enter it in. Okay, let's look at the last one here. Again, that setup should be becoming automatic for us. And we cross multiply. X and x is x squared. 7 and 11 is 77. Square root. So x is the square root of 77. 77 breaks down into 7 and 11, and that's it. That's the prime numbers, and those do not make a perfect square. Okay, they're not the same. I can't do anything with them. So I multiply them back together, and my answer here is the square root of 77. Okay, so a little bit of recall there. We're going to have a little bit of more recall. Let's talk about what an altitude is. Now, an altitude of a triangle is the segment that joins a vertex. So really we could have 3 because we have 3 vertices, 3 corners to a triangle, and the opposite side forming a right angle. They need to be perpendicular. Okay? So if I look at my first triangle here, start from there, and I would draw a segment to the other side and make it perpendicular. Okay? Yours are already going to be given, so mine's probably not perfectly a right angle, but that's how we figure this out. That's what an altitude is. Here, I can pick any of my 3 vertices to do it. I'm just going to use the top one, but really it could come from any of them. We want to draw a segment that is perpendicular to the other side. Over here, I'm going to use this one, and I would draw that as an awful line. Draw a line that is perpendicular to the other side. Okay? Now, really, this unit, all of Unit 7 is about right triangles, so we're focusing on this one. Okay, and this is what our pictures are going to look like over the next 2 days. I'm going to have a right triangle that then has an altitude drawn to the side across from it from the right angle. Okay? Now, why are we focusing on this right triangle? Why this one in particular in this unit? What's so unique about it? Well, what happens is when we have that altitude, we get 3 similar triangles. Okay? Now, I could go through and I could show you all of them. I am going to draw the picture. They're all similar by angle. Okay, they all have a right angle, and then at some point these triangles all share an angle with another triangle. Okay, so look, we have the big triangle, and we have this little triangle and this little triangle here. Okay, what I'm going to do is I'm going to redraw them so that you can see how they all relate, and I'm going to start with that big triangle. And forgive my drawing here, this isn't going to be perfect, but this is A, B, and C. Okay, B is my right angle. AB is the short side, BC is the long side, AC is the hypotenuse. Okay, now I'm going to draw, I'm going to distinguish these. One's going to be a heart, one's going to be a star. I'm going to draw the one with the heart because it's the next biggest triangle. Okay. So I'm going to draw it so that matches the way this one looks, the bigger one. Okay. Well, its right angle is here at D. So D goes here. Its short side is BD. So B here, and then I have C out here to the side. Okay. Now remember I said they were similar by angle. Well, they're both sharing a right angle here, and then they both have angle C in common. That's how they're similar. Now, I'm going to do so this is the heart one, and then we have the star here, the smallest one. Draw it in the same formation. Okay. Well, its right angle is also here at D. Its short side goes up to A, and then B forms the hypotenuse. So if we look at this one, it has 2 right angles, and it is similar to the big triangle here. Okay, so these two are similar, and these two are similar. Okay, that's what we end up with. Now, why? Why is this important? Well, let's look at the next slide here. What can we do with that? We can set up proportions. Okay, so if we have those 3 similar triangles, remember we had the big triangle, and then we had the medium triangle, and then we had the small triangle. This is a very crude sketch, but what we can do is we can say, well, this side over this side is equal to this side over this side. We can solve for parts of the triangle. Or this side over that side is the same as this side over this side. Okay? So this side, or this slide in particular, not super important, but the goal I want you to see is that we can set up proportions. Okay? Really, the shortcut here I want you to remember is called the loop. Alright? And it's going to save you some time, because I really don't want you to redraw. You're at home right now, and I'm not there to answer your questions. I'm not going to have you redraw all of these triangles. I'm going to have you use this shortcut called the loop. Now, the loop goes from the ends of the hypotenuse of the big triangle. Okay, so it starts here at A, and its goal is to get to C. Now we call it the loop because we're going to loop around like that. Okay, this is how we use this particular type of problem, because what's going to happen is you're going to have a value here, a value here, and a value here. And we're going to set up a proportion. Okay. Now over here to the side, I'm going to write it out with letters, and then as we do the examples, I think you're going to see it. It's going to make a lot of sense to you. So the first thing if we're going from A to C, we hit is AD. The next thing we hit is DB. So that is, I'm going to change my pen color here for a second. Change it to red. So So this is what I hit first, and then I come over here second. Now, that's going to equal, I'm coming back, remember this is a loop, this part. So I need to have D be a second time, and then we come over here, DC is the fourth. Now, if we look at this, what do you notice about these two here? They're the same. And we said this whole idea is about using the geometric mean. Well, remember on the geometric mean, these two things were the same. They were x's. So that's how these go together. This particular type, this set of problems with this right triangle, we get to use the geometric mean on every one of these. Well, the setup is the same. We're using the loop, but it all comes back to that idea of the geometric mean, where dB, that variable that could be on that altitude there, is the same value, and it fills in the means of our proportion. Okay? And then we would solve this as we normally would. I think it's going to make a little more sense as we do some examples. And I've labeled the examples by the type that they are. So example 1 here is going to be finding the altitude. Okay? So notice in our problems, the variable is on that altitude. We're going to use that idea of the loop. So I'm going to start here at A, and my goal is to get to C. Well, I'm going to go A, D, B, D, C. Okay? So really, AD over DB, DB over DC. Okay, they're going to be the same. I do not need to see this every time. That's just to help you remember what we were doing. So I'm going to look at these values. The first value I hit is 9. And then I come to the x. I'm going to repeat that value. So another x, and then 16. Okay? Make sense? Cross multiply. X squared equals, now you may need a calculator for this, 9 times 16 is 144. We square root both sides. That's a perfect square, so x is going to be 12. And you're done. You found the value of x. Now that was a nice one. It was a perfect square underneath the radical. You may get ones that don't have a perfect square. That's okay. Remember, it'd be a square root b. In Schoology, if this is it, and it's in that formula a square root b, 12 is your a, and then b, you have two options. You can put 1 or you can put na because the square root's not applicable to that particular problem. Okay? Let's look at the second one on this part here on example 1. Now, I gave you the whole part here. We said that that's 20. You have to do a little bit of thinking because we need this part here in order to use this whole idea of the loop. Well, if the whole thing's 20 and I already know 5 of it, 20 minus 5 is 15. So that's that other part. Do not be confused on this because that step is super easy. You do need to have both parts here of that hypotenuse in order to use this. So I'm going to change my pen color because I'm seeing a lot of red. Let's go back to green. Okay, we want to start here at A and we want to get to C. So loop it around. Okay, first value I hit is 5 over x, that's the next thing, equals x over 15. Okay, well, x squared equals 5 times 15, that is 75, square root both sides. This is not a perfect square, square root of 75, so I'm going to try to break this one down. And I'm going to use the two numbers I multiplied to get it. I multiplied a 5 and a 15. 15 is really 5 and 3, so my prime numbers are 3 and 5 and a 5. 5 makes my perfect square, so 5 square root 3, that would be my answer. And again, 5 would be A, 3 would be B in Schoology. Okay? Now I'm going through that breakdown part a little fairly quickly because we spent a whole little unit earlier on how to do that, so I'm pretty sure you guys are good with it. Your homework scores have been pretty good, so I'm skipping through that fairly quickly. So that's example 1, finding the altitude. Now, the variable can be moved around on these problems. It doesn't have to be on the altitude, but I'm given a value on the altitude. That's what tells me it's this type of problem, the loop problem. So if we look here, I've labeled this finding part of the hypotenuse, because we're going to find from D to C. We're not finding the whole thing, just from D to C. We're going to loop it around. What's different about this one? It's going to be 6 over 8. Have a value on that altitude, and that value is going to get repeated. Okay? So here, since I don't have two x's, there's not going to be a square root. I'm not going to have to break down a radical anywhere. I just cross multiply this. 6x equals 64, and I divide both sides by 6. 64 divided by 6 is, I do get a weird decimal. I get 10.6 repeating. Okay, I don't want that. I want it as an improper fraction in the calculator. So I use my in Schoology. I can use my calculator and switch it, and I get 32 over 3, and that would be the answer that I want. Okay, so again here, same idea, using the loop, but that x is in a different spot, so I still set it up the same way. I just happen to not have to use a square root on this one. Okay, last one, example 3, finding the hypotenuse, finding the whole thing. Okay, well, if I look, I have a value on the altitude, so that tells me I'm going to use this loop. Okay, my value here is all of this. So really, I need to know what DC is, and if I know what DC is, I can add AD and DC together to get the whole thing. So what I'm going to do is I'm going to add myself a variable here. I'm going to add a y, and I'm going to solve it just like I did example 2. 3 over 9 equals 9 over y. Okay, and I added that variable in. I'm going to cross multiply. 3y equals 81. Divide by 3, so y is 27. Okay, so now if I'm looking here, I know that this part is 3 and this part is 27, and I want the whole thing. So what would I do? Add them together. 3 plus 27 is 30. Okay, this is kind of the opposite idea of what you did on this example right here. Okay, finding the altitude, the second one, the one there in green, where we subtracted what we knew from the hypotenuse. Well, for this one, we have to figure out that missing part and then add the two together. Okay? All of your problems on your homework are going to be this type, the loop type. What you're going to have to do is figure out where that x is. Is it in example 1, where we're finding the altitude, example 2, finding part of the hypotenuse, or example 3, finding the whole hypotenuse? Okay, so what I have for my recap here is for you to look at what you have. Okay, first thing is you have to have a value on the altitude, and then figure out where the variable is. That's going to tell you what example to look back at. Okay, example 1, example 2, example 3. Now example 1 was split into two different types, one where we had the whole hypotenuse and had to subtract, one where we just were given both parts. Okay, so that one could be two different types of problems, but look at what you have because it will tell you which example to go back and look at. Okay, you do have an assignment in Schoology. If you have questions, please post them to the discussion board.